Hey Coyotes, we are playing Name That Sequence. Name that sequence. This is a pretty common problem they like to give you with these sequence problems. They'll give you a sequence and you have to decide if it's arithmetic or geometric or neither. Arithmetic, geometric, or neither. And then usually they'll say, if it's arithmetic, what is the common difference? If it's geometric, what is the common ratio? Okay, so let's look at number one. 15, 10, 5, 0, negative 5. There seems to be a pattern here. Does it look like we're adding the same number over and over again? Oh, well, I don't know. They're getting smaller. Maybe we're multiplying by a fraction. You got it. We're subtracting by 5 each time. But subtracting by 5 is the same as adding a negative 5. So we're adding a negative 5 each time. Therefore, this is an arithmetic sequence. And the common difference then, if I subtract a sub 2, the second term minus the first term, 10 minus 15 equals negative 5. If I subtract the third term minus the second term, 5 minus 10 is negative 5. I'm getting the same difference, or a common difference. Therefore, D equals negative 5. All right, let's look at the second one. 3, negative 12, 48, negative 192. Whoa, what is going on here? Well, it doesn't look like we're adding or subtracting, because I would need 3 minus 15 to get to negative 12, but negative 12 minus 15 is not going to make positive 48. Okay, so based on one of our prior videos, what happens when you see positive, negative, positive, negative? Think about it. Right, that's when we're multiplying by a negative number. So what number are we multiplying by? 3 times negative 4 makes negative 12. Negative 12 times negative 4 is going to put that back to a positive, 48. 48 times negative 4 is negative 192. So this is a geometric sequence. And what's the common ratio? Well, we know it's negative 4. But the way that you find out what the common ratio is do the second term, a sub 2, divided by the first term, a sub 1. So the common ratio is negative 12 divided by 3, which reduces to negative 4. Let's just make sure it really is the common ratio. Let's do the third term divided by the second term. 48 divided by negative 12 equals, you guessed it, negative 4. So our common ratio is negative 4. All right, third example. 2, 4, 8, 10, 14, 16. Looks like we're multiplying by 2. 2 times 2 is 4. 4 times 2 is 8. But 8 times 2 is 16. So it's not geometric. So is it arithmetic? 2 plus 2 is 4. 4 plus 2 is 6, not 8. So it's not arithmetic. It's not geometric. It's a pattern. It's 2, 4, and then it skips 6. 8, 10. Skip 12, 14, 16. So there is a pattern there. It is a sequence, but it's not arithmetic and it's not geometric. It is neither. And the various textbooks get very clever at coming up with sequences that look like they might be arithmetic or geometric to really make sure you know what you're talking about. Okay, so how do you know if it's arithmetic? Subtract the second term minus the first term. Then subtract the third term minus the second term, and if they match, probably looking at an arithmetic sequence. How do you know if it's geometric? Divide the second term divided by the first term. Then divide the third term by the second term. And if you get a match, you are probably looking at a geometric sequence. All right, have fun with those problems, and I will see you Thursday, and we will look at what is the explicit and recursive formulas for a geometric sequence.